Today we discussed about introduction to compiler and its phases. First one, what is meant by a compiler? Compiler is just a translator that translates a high-level languages into a low-level languages. What is meant by a high-level languages? High-level languages means human easily understandable languages like Java, CPP, like that. What is meant by a low-level language? It is a binary code that is machine understanding languages. Input of a compiler design. It is a source program that is a high level language. Output it is a target program that is the binary code. Let us consider this example. In this example, source code is a CPP programming. It is a high level language programming. Output it is a binary code. It is a target code. How compiler translates this source code to a target code? How this compiler translates this high level to a low level? It uses a sequence of processes that is called phases of compiler designs. In compiler designs generally include 6 phases. First 3 phases generally called front end or analysis part or machine independent part or language dependent part. Last 3 phases are called synthesis part or machine dependent part or language independent part. In these two parts phases included sequences of sub processes that is called phases. This is a detailed structure of phases of compiler designs. It included 6 phases: lexical analyzer, syntax analyzer, semantic analyzer, intermediate code regeneration, code optimization, and final target code generations. All 6 phases attached with a symbol table and error handling routines. The symbol table or syntax table, this is attached with the all 6 phases. That is the main data structure used in compiler designs. It includes the structure of identifiers and it is general details. Error routines. It is also attached to 6 phases. It generates an error based on any mismatching of any one of the phases. Next one, first phase, that is lexical analyzer. The function of a lexical analyzer, it converts the program into tokens. Token is the meaningful characters that is called tokens. The format of a token is token name and attribute values. The other function of a lexical analyzer, it keep the line numbers and skip the command lines and white spaces. That are the other functions of a lexical analyzer. The output of a lexical analyzer, it is a sequence of tokens. This is the input of next pages, that is syntax analyzers. Next, just let us consider an example. New value equal to old value plus 12. This is the statement included in a high level language. This is the input of lexical analyzer. The function of a lexical analyzer, it converts into sequence of tokens. The output of a lexical analyzer is this. New value means it is an identifier, equal to is an assignment operator, old value it is also an identifier, plus is a add operator, 12 is a number. Like that, all variables are converted into tokens. And also remove the white spaces and command lines. Next one is syntax analyzer. It is also called parsing. The function of a syntax analyzer, check whether the token stream meets the grammatical specification of the languages. If it matches the grammatical specification of the language, then it generates a syntax tree. Otherwise, it generates a syntax error. The specialty of a syntax tree is interior node represent an operations and child node represent an augmentation of the operations. This is the example representation of syntax tree. In the syntax tree, new value, old value, 12. These are new value, old value. This is the identifier. This is the child of syntax tree and equal to plus. These are the operators. Next 12. This is the integer value. Third phase is semantic analysis. In semantic analysis, input is a syntax tree. Output is semantically verified syntax tree. In syntax analysis, it checks it's semantically correct or not. It includes type checking, data type conversions like that. It's semantically verified. In this example, new value equal to old value plus 12. It check data types. New value, old value, data type checking. The data type of new value must matches with the type of old value, otherwise it generate an semantic error. If it's syntactically correct but semantically not correct, then it generate a semantic error. In this example, syntactically correct but semantically incorrect. Let us consider this example: sum equal to a plus b. A and b are a integer and b is characters. Then the operation is addition. Then sum is a double character. Double data type is double. Then data type mismatching. So it generates a semantically error. Next step is intermediate code representations. It is an intermediate representation. It is used to easy to generate the target code, and it easy to generate the binary code. There are so many intermediate code representations are there. 3 address code, 4 address code, like that. Intermediate code generation, it is a bridge phase between the analysis and synthesis phase. This is the intermediate representation of the example: new value equal to old value plus fact into 1. First it generated into a tokens. Identifier equal to identifier 2, identifier 3 into 1. Temp1 equal to into 2 real conversions. It is a 3 addresser format. Then all operations included 3 operands. Results 2 operands. Temp2 equal to identifier 3 into temp1. 3 operands. Temp2 identifier 3 temp1, and results is stored into temp2, like that in 3 address form. In 4 address form it includes 4 operands. Next one is code optimization. In code optimization, that reduce the space. It means it faster execution, shorter code, and it consumes less power. It also significantly improves the running time of target program without slowing the compilation is too much. Based on the code optimization, the total performance will improve. Basically, two type of code optimization: machine dependent and machine independent. That includes so many code optimization techniques like loop optimization, loop unrolling, folding, redundancy elimination, strength reduction, algebraic simplification, like that. So many code optimization. This is the code optimization based on our example. Total number of code will less after the code optimization. Then next phase is the final target code representation. Sir, this is the final translation of source code to binary code. This is the target code based on our example: identifier 1 equal to identifier 2 plus identifier 3 into 1. Based on this example, the final target code is a machine code. Like that, all high level languages, it is converted into a low level languages in compilation process. This is the small representation of phases of compiler design. That's all.